All right. So Wechsler, for Wechsler adult, for the Wechsler adult intelligence scale, the mean is 100, the standard deviation is 10. Right? If WIS IQ is normally distributed, what's the probability? What's the probability that the population has an IQ of first greater than 120, less than 87.5, and between 93 and 160? So here we've been given a normal distribution. All right. The first thing we have to do is we have to standardize this normal distribution. All right. We standardize the normal distribution using the z-scores. Remember, the z-scores tell us how many standard deviations a point is from the mean. Right. So let's just draw. Let me draw a normal distribution curve. All right. We've been told our mean is 100. All right. The mean is at the center in a normal distribution curve. All right. And the standard deviation is 10. So we have 110 here, 120. Right. Here we have 90. We have 80. All right. Then you have your, and so on and so forth. Then you have your standard, your normal distribution like this. All right. Now we have to standardize this normal distribution. Okay, we have to standardize it, right? So the formula for the z-score, all right, we have to get our z-scores. Our z, it's z equals x. X is our data point, all right. The data point we'll be looking at minus the mean, all right, minus the mean divided by the standard deviation. All right. So the standard normal distribution will look like this. All right. You draw a line here. All right. The mean is 0. Then here we have 1, 2. Here we have -1, -2. All right. So this is what we're trying to do. We're converting this normal distribution here, this normal distribution, to the standard normal distribution. That's all that is happening here, right? So for our first one, they told us we have to find the probability that the IQ is greater than 120. All right. So in this case, our X is 120. You say X equals 120. All right. We get our Z score. So it says Z equals 120 minus the mean, which is 100, divided by the standard deviation, which is 10. 120 minus 100, that is 20. 20 divided by 10 is 2. All right, so this score is 2. All right, so it's located somewhere here. All right, it's located somewhere here. We have put the dashed lines. Right, the same place where there's this 120. This is where our 2 is located, right? This 120, when we standardize it, it becomes this 2 here, all right? So now I find the probability that it's, is it greater than, or less than? Probability that it's greater than 120, all right? So with my z-score tables, it gives the probability which is less than, all right? If you're using the other z-score tables, which gives the probability greater than, you can easily get your answer. All right. So the area we're focusing on is this area. This area is greater than 120, and the shaded area is less than 120. All right. So let's find the probability of the shaded area, which is less than 2, not 122, which is less than 2. Right. So we'll go to our z-score tables. All right. We go to our z-score tables. All right. So we're looking for a z-score of 2. All right. So here 2 and the well, in the row of 2.0 and the column of 0.0, okay? Because our z-score is 2. So this column of 0.0 and this row of 2.0, it intersects here at this probability of 0.99772. All right. So that probability, which we have been given on the z-score, this is the probability less than 2. All right. This is the probability less than 2.
Excuse me, sir.
Yes, Mr. Charles, how are you? Yes.
I don't know if it is my phone or it's your phone.
It's your phone. It's your phone. Are you able to get me clear now? Are you able to get me now? Okay, so our probability, which is less than our z-score 2, is 0.9772. All right. This shaded area represents 0.9772. So want the probability, all right, on the probability that our z-score is greater than 2. All right. Our probability that our z-score is greater than 2. All right. So we're going to say 1 minus 0.9772. Because remember, we're interested in this area here, right? This area which is not shaded. This is the area greater than 2. So we're interested in this area, which I'm now coloring in red. This is the area we are interested in. All right. So you're going to say 1 minus 0.9772. You get 0.0228. If we convert that into percentage, that's like 2.28%. All right. So that is the probability that the IQ is greater than 2 in the z-score format. Then when we talk about our x value, which is 120, probability that the IQ is greater than 120, we say it is 2.28%. You can leave it in decimal or percentage, whichever. All right. Yes. Any questions, queries, concerns? We're okay with this. Mr. Charles, are you okay?
Someone,
Yes, Mrs. Chulu.
I think me, I'm confused.
Okay,
Why you get the 10?
okay? What's happening here is you've been given a normal distribution. Okay, you've been given a normal distribution, right? For these people's IQs. All right, they've told you that the mean is 100. All right, and the standard deviation is 10. All right. So the normal distribution is. Have you seen this first graph I've shown here? This one here. This is the normal distribution which I'm circling around here. All right. That's the normal distribution. Your mean is 100. The mean is always at the center. The standard deviation is 10. So you just be moving in units of 10. Okay. 100, 110, 120 on the right side. And on the left side, 90, 80, and 70. Are we okay with that, Mrs. Chulu?
Yes, sir.
All right. So now what happens is you have to standardize this normal distribution. All right. You have to standardize it. All right. So the standard normal distribution has a mean of 0. All right. And a standard deviation of 1. All right. The standard normal distribution has a mean. Our mean is 0 and a standard deviation of 1. Let me see. As you can see, 0, 1, 2. We're moving just in increments of 1. So after you standardize, all right, after you've standardized the normal distribution, you have to get your z scores. Okay, you have to get the z scores. So to get your z score, you use this formula. Right? Remember, the z score just tells you how many standard deviations your data point is from the mean. All right. How many standard deviations the data point is from the mean. So this is the formula for the z-score, all right? X, which is your data point, minus the mean divided by the standard deviation. Are we okay with that, Mrs. Chulu?
Yes, sir.
All right. So now what's happening here is, since we're getting our z-scores, we've been told first, we have to find the probability, okay, as the question says, probability that the IQ is greater than 120. So in this case, this 120 is your X, okay? This 120 is your X, all right? All these numbers here are going to be your X's when you're finding your Z-score. All these numbers will be your X's, all right? So you're going to say 120 minus 100. Remember, the mean is 100. Standard deviation is 10. All right. So 120 minus 100 divided by 10. That's how we got 2. Our z-score is 2. All right. Mrs. Chulu, are we okay with that? Our z-score is 2. So if we locate our z-score on the
Yes, sir.
graph, all right, our z-score is already located for us here. This part here, which have this red line I'm drawing here. This is where our z-score is located. All right, it's 2 standard deviations away from the mean. This red line which I've put here. Now, this is where you're going to have to go to your tables. All right, you're going to have to get your tables to find the probabilities. Okay, so these tables, like this table, the tables I'm using, they give you the probability to the left, which means less than the z-score, right? Your z-score is here. Then the shaded area, this is the probability which is less than your z-score. All right. If your graph, this white part is the one which is shaded, then it's giving you the probabilities greater than your z-score. All right. So in our case, we're going to first find the probability which is less than our z-score of 2. After we determine that, we'll find the probability that the IQ is greater than 120, which is also this 2 here. This 2 represents the same 120. So I'll find the probability, right, that it's greater than 120. And in case in the z-score, we're talking about the probability it's greater than 2. All right. So you're talking about this region here. This one I've shaded here in red. This is the probability which is greater than our z-score. All right. This region here. This is the probability greater than 2. All right. The probability greater than 2. So on our table, since our z-score is 2, all right, Mrs. Chu, our z-score is 2, you come to your tables, all right? You look for the row 2.0, which is here. This is the row of 2.0. Then you're going to go to the column of 0.00, all right? The column of 0.00. Here, this column here. Because our z-score is just 2, right? So where they intersect, that's the probability less than our z-score. All right. So here's the probability 0.9772. This is the probability less than our z-score. Are we okay with that, Mrs. Churu? This shaded region in green, right, represents this probability here, 0.9. So now since we want the probability which is greater than 2, you're going to subtract 1 minus 0.9772. And that's how we got 0.228. All right, that's how we got 0.228. All right, so the probability that the IQ is greater than 20 is 0.228. All right, this is the probability that the IQ is greater than 20. All right. Are we okay with that, colleagues?
Yes, sir.
Okay. The next one is they've told us the probability the IQ is less than 87.5. Right? Probability IQ is less than 87.5. So what you're going to do again, you are going to get your z-score. All right. You're going to say z-score equals x minus mu, which is the mean, divided by the standard deviation. So our x in this case is 87.5. All right. Then our mean is 100. Right, and the standard deviation is 10. Right, so 87.5 minus 100, what do we get? Someone with a calculator. Maybe while in the offices we can't calculate. It's negative 12.5. Negative 12.5 over 10. 10 divided by negative 12.5, you get negative 2, negative 1.25. Right, negative 1.25. So that is our z-score. All right, on the standard normal distribution, we have 0 here, and we have negative 1 here. So we'll say this is negative 1.25 should be Negative 1.25 should be somewhere here. No, here. 0, -1, -2. So negative 1.25 is here. Let me just draw it proper. I'm doing a recording. I'll call you back. So I'm doing a recording. I'll call you back. Yes. Oh, let me see. Try to join again. I haven't seen. Yes, negative 1.25 is somewhere there. All right. Here we have 1 and 2. All right. This is where our z-score is located. Negative 1.25. All right. So we're going to go to our table now. All right. We're going to go to our table. This shaded area represents the probability less than negative 1.25. So you go to your z-score tables, the negative one. You look for negative 1.25. So here's our negative z-score table. All right. So we're going to look in our row. We're going to have negative 1.2. All right. Then in our column, we're going to have 0.05. Right. 0.05. So our column is here, 0.05. Then we have negative 1.2. So 1, 2, 3, 4, 5, 6. So this is our probability, 0.1056. Right? 0.1056. This is our probability less than. Are we able to see it? Should I zoom in more? 0.1056. Let me just ensure that I'm on the correct column. 1, 2, 1, 2, 3, 4, 5, 6. Yes. 0.1056. That's our probability less than. All right. So you're going to say probability that z is less than negative 1.25 is 0.1056. So in the same manner, you can say that the probability that x is less than 87.5, all right, is 0.1056. And that is your answer. And can convert it into percentage. That should be 10.56%. Any questions, clarifications? All right, we can move on. The next one is between 93 and 116. Right? Between 93 and 116. So what you're going to do, you work on both of them separately, then we subtract. All right. So I said between 93 and 116. All right. So you're going to say x equals 93. We find our z-score here. So I'm going to say z equals x minus mu, which is the mean, divided by the standard deviation. Right, so we're going to say 93 minus 100 divided by 10. That gives us 93 minus 100, that's negative 7 divided by 10. So our first z-score is negative 0.7. All right, our first z-score is negative 0.7. Then our second z-score, is the second one we have to tabulate for, is when x equals 116, because we want to find the probability between 93 and 116. So you're going to say z equals x minus mu divided by the standard deviation. So that's going to be 116 minus 100 divided by 10. 116 minus 100, you get 16. 16 divided by 10, you get 1.6. And so on our normal distribution curve, our standard normal distribution curve, we have 0 here. We have negative 0.7 somewhere here. Put it here, negative 0.7. And we have 1.6 somewhere here. All right, then here we have negative 1. Yeah. Just put them in a presentable manner. Okay. So we have 0. We have, say here 1. Here we say negative 1. Negative 2. All right, and here we're going to have 2. So we get our points now. We said negative 0.7 negative 0.7, it's somewhere here. All right, it's somewhere here. Okay, that's negative 0.7. And then 1.6 is somewhere here. So we want the probability of this shaded region here. All right, want the probability shaded region. So we're going to go to our z-score tables. All right, we find our probabilities. Then after we find our probabilities, we just subtract. So let's start with negative 0.7. All right, negative 0.7 on our z-score table. All right, here we have negative 0.7. In our column, it will be 0.00. This is your column here. There's 0.00 column because it's just negative 0.7. All right, so find the probability here. probability is 0.2420. All right. Probability is 0.2420. And probability of z-score is less than negative 0.7 is 0.2420. Let me just put it in a orderly manner. Okay. Negative 0.7 would be 0.2420. Right. Then also find probability of our z-score here 1.6. Right. Probability that z is less than 1.6. We go to our positive z-score table. I'm going to look for 1.6, which is here. And the column for 0.00 is this one, this column here. So our probability is 0.9452 here. 0.9452. Right. So our probability, right, that our z-score is in between negative 0.7 and 1.6, right, going to be 0.9452 minus 0.2420. All right, so 0.9452 minus 0.2420, what do we get? 9452 minus 0.2420, we get, 0.7. Okay, our probability is 0.7032. All right, so that is our answer. All right. Whenever we have a number which is in between, all right, you're going to get each of the z-scores, tabulate their probabilities, and then you subtract. All right, you're going to subtract. So the answer is this one. Probability that here it was 93. That the IQ is between, okay, this X represents the IQ. The IQ is between 93 and 116 is 0.7032. Questions?